Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in today's video, we are focusing on this M1 paper, and this is paper 4 mechanics, and it's of May-June 2024, variant 43. So let's get started. The time is 10:39. It's a walkthrough solution. That means the paper is already solved, and I'll be going over the solution. It's 9:39 p.m. And let's see how much time will it take. Only the last question, last part, I'll solve it fresh. So now the first thing, two particles P and Q of mass 0.2 and 0.5 kg. So this one is P, this one is 0.2 kg, this one is Q, that is of weight 0.2, mass 0.5 kg. They both are at rest on a smooth horizontal plane. Particle P is projected towards with a speed of 6 meters per second. That is 6 meters per second directly towards Q. So P is projected in that direction. Now it says after P and Q collide, P moves with a speed of 1 meter per second. So it's moving with a speed of 1 meter per second. Find the two possible speeds of Q after the collision. So now there is a possibility that P would be moving to the right 1 meter per second, or there is a possibility P is moving to the left at 1 meter per second. That is the two cases. So momentum before collision equals to momentum after collision. 0.2 into 6 plus 0.5 into 0. That's the same thing in both the scenario. 0.2 into 1, that means it's moving in the same direction. 0.2 into -1, it's moving in the opposite direction. And we don't know what is the value of V. That is what we are looking for. So over here, V comes out to be 2. Over here, V comes out to be 2.8. These are the two possible speeds of Q after collision. A simple basic question. Question number 2. So now it says a particle of mass 0.2 kg is attached to one end of a light and extensible string. That is the string over here. The other end of the string is attached to a fixed point on a vertical wall. That is a fixed point. The particle is held in equilibrium by a force of magnitude x Newton. So there is a force of magnitude x Newton. It is acting at right angles to the string, perpendicular to the string, with the string taut and making an angle of 30 degrees with the wall. So this angle is 30. So let me draw the perpendicular. That's right over here. Therefore, this angle is 60 degrees. What is the rule that I follow? The rule that I follow is that make sure angle is with the horizontal. So therefore, the horizontal component always has a cos. The vertical component always has a sine. So T is resolved vertically. T is resolved horizontally. X is resolved horizontally. X is resolved vertically. This is 60. This is 30. This is 90. Altogether, it's 180. So now it's in equilibrium. That means force acting to the right should equal force acting to the left. Forces acting up should equal forces acting down. So look over here. X cos 30 is T cos 60. That is written. Let me simplify it a bit. So therefore, X is equals to T cosine 60, which is half divided by cosine 30, which is √3/2. So the 2 and the 2 cancels out. So X is 1/√3 times T. That's one equation. T sine 60 plus X sine 30. T into √3/2 X sine 30. X into half is equals to 0.2 into 10, which comes out to be 2. So therefore, T √3 plus X divided by 2 is 2. Therefore, T √3 plus X is equals to 4. That is the second equation further simplified. This is the first equation further simplified. Now, X is 1/√3T, which can also be written as √3/3T. This is after rationalization. So T √3 and X is √3/3. T is equals to 4. So therefore, 3√3 plus √3T divided by 3 is equals to 4. And this is, there is a T, don't forget. So that is 4 √3T is equals to 12. and this is root 3t equals to 3. Therefore, t is 3 divided by root 3, which is root 3 over root 3. Therefore, t comes out to be root 3. That is the answer right over here. And x is root 3 over 3 into t, which is root 3. And this comes out to be 3 over 3. Therefore, x comes out to be 1. So it's a beautiful question in which everything is coming out in the exact form. Now over here, question number 3. Now this question says, a car travels along a straight road with a constant acceleration a meter per second square, where a is greater than 0. The car passes through points A, B, C in that order. The speed of the car at A is u in the direction AB. So that's AB and C. It's moving in this direction. The distance BC is twice that of the distance AB. The car takes 8 seconds to travel from A to B and 10 seconds to travel from B to C. All the information is listed over here. Find u in terms of A. Find the speed of the car at C in terms of A. So now, whenever such a question comes, we know that the initial speed is at A, at B, it will be different, at C, it will be different. So take two things. The first part, that is the length AB, and this is the length AC. Now, for length AB, the distance is S, time is 8, initial speed is U, and acceleration is A. So they have not mentioned acceleration. Let me write this thing as a meter per second square. So make an equation S is equals to ut plus half at square. So there it is. This is S is equals to ut plus half at square. Over here, the same thing, but this time the distance is 2s and the whole distance is 3s. So that's how the next equation is made. Now we have two equations. What have I done? I have taken this s over here and I have replaced it over here. So this whole thing over here, it's over here. And you simplify and you get this thing, u is equals to 11a. Very basic calculation without no use of the calculator, without the calculator. Now it says the last part. It says find the speed of the car in terms of a. We know that v is equals to u plus at. So u is 11a, a is a, t is 18. That's the time for the whole journey. So 11 plus 18, that is 29a. That's the speed of the car in terms of a. So now 3 questions are down. Question number 4. Now it says a particle travels in a straight line. The velocity of the particle at t time t seconds after leaving the point O is this thing. That means the particle initially, the particle was at O. That means displacement from O is 0. This is important. It will be used up later. Now this is the equation V in terms of t. There is a constant k over there. The distance traveled by the particle in the first 2 seconds of its motion is 6 meters. Now you may be wondering, is there any turning point in between? That is why they have written. You may assume that v is greater than 0 in the first 2 seconds of the motion. That means it's not turning around. If it's positive, it's positive. Because when t is 0, v is 3, v remains positive. That means it's not turning around. Find the value of k. So that's the velocity equation. Integrate each term, integrated according to the rules of P1, we get a constant of integration C. Since they have used K, you should use some other constant. C is the best one. When T is 0, S is 0. So let me highlight this. When T is 0, S is 0. Therefore, C comes out to be 0. Rewrite the equation once again, which is this equation over here. Now plug in the next condition. When T is 2, S is 6. So this is given over here. That's right over here. In the first 2 seconds, t is 6. And that was the first condition. T is 0, S is 0. Therefore, k comes out to be 3. Therefore, what are they looking for? They're looking for the value of k. So k is 3. In other words, the velocity equation is 3t square minus 4t plus 3. Now they're asking for the minimum velocity of the particle. You don't need to show that velocity is a minimum. That means you don't need the second derivative of velocity. It's not applicable, not needed at this moment. So v is this. Therefore, dv by dt is acceleration. That comes out to be this. Whenever you have to find the turning point of any quantity, the derivative of that thing. If they are talking about velocity and they're talking about max or min, then dv by dt should equal to 0. So dv by dt equals to 0, t comes out to be 2/3. What are we looking for? We are looking for the minimum velocity. So now let's plug in t is equals to 2/3 in this equation, simple calculation, and then we get this answer. I did it without a calculator. There is no harm in using a calculator. That's personally your choice. So now let me pause for a second. So now let's look at this question number 5. It says a van 4,500 kg is towing a trailer of mass 750 kg down a straight hill inclined at an angle theta to the horizontal where sine theta is 0.05. So now instead of giving us the angle, they have given sine of that angle so that there is no issue of accuracy. The van and trailer are connected by a light rigid tow bar which is parallel to the road. There are constant resistive forces of 2,500 on the van, 300 Newton on the trailer, and it's inclined and they are connected. It is given that the tension in the tow bar is 450. So this value is given. Find the acceleration and this thing of the force and the driving force of the van's engine. So now are they moving down or moving up? That needs to be said. For is towing a trailer down a straight hill. So it's moving down. That is the first thing that you need to realize. mg sine theta for the van down, mg sine theta for the trailer down, tension for the trailer pointing down, tension for the van pointing up, acceleration is down, resistive forces naturally in the opposite direction. Make one equation for each particle, F plus mg sine theta for van minus 2,500 minus t is equals to 4,500A. And then tension minus 300, tension plus mg sine theta minus 300. Tension plus mg sine theta for the trailer minus 300, that's the resistive forces as mass into acceleration. So now, first of all, if I use the second equation, everything is known except for A. I find the value of A. I plug the value of A over here. I find F, which is the driving force. That's how this first part is done. Very simple. The second part. On another occasion, the van and the trailer, it's the same van, same trailer, ascends. So now it's moving up. Ascends a straight hill inclined at an angle alpha, where sine alpha is 0.09. Now it's a different hill. The driving force of the van's engine is now 9,100 and the speed of the van at the bottom of the hill is 20. That will be used later on. The resistances to the motion are unchanged. Find the acceleration of the van and the tension in the tow bar. This time, tension is unknown, acceleration is unknown. And also, later on, find the speed of the van when it has traveled a distance of 375 meters up the hill. Now, that is nothing special. Initial velocity is 20, acceleration is positive, distance is 375. That is basic kinematics. That's for 2 marks. For 5 marks over here, the same working, similar working to that. Engine force up, mg sine theta for trailer down, mg sine theta for van down, resistive forces. For this and this down, alpha is changed, acceleration is up. 9,100 minus tension minus 2,500 minus mg sine theta. Look at all the terms, is equals to mass into acceleration. Tension minus 300 minus mg sine theta is mass of van into acceleration. Again, this time when I add both of them, I'll cancel. I'll first find the value of A, then I'll find the value of tension. So that is basic working. Question number 6. A cyclist is traveling along a straight horizontal road. It's a straight road. The total mass of cyclist and a bike is 80 kg. There is constant resistive force of magnitude 32 Newton. At the instant when she is traveling at 7 meters per second, her acceleration is 0.1. Find the power output of the cyclist. So this is a simple application of resultant forces mass into acceleration. Now we know that force is equals to power divided by speed. So power is P, speed is 7 minus 32 is equals to mass into acceleration. Therefore, 8 plus 32 into 7, that comes out to be 280 watts. That is the power output. The second part. Now it says find the steady speed. Steady speed, that means acceleration is 0, that the cyclist can maintain if a power output and the resistance force are both unchanged, resistance force or resistive force. So now 280 is the same. V is what we are looking for. This is 32. Acceleration is 0. Therefore, forward force and backward forces are equal. Therefore, V comes out to be 8.75. Let's move on. The cyclist later descends a straight hill of length 32.2 meter. Now it's going down and inclined at an angle of sine inverse 1 over 20. That means if I label this angle as theta, sine of theta is 1 over 20. Her power output is now 120 watts and the resistive force has a variable magnitude such that the work done against this force in descending the hill is 1128 joules. So now the time taken to descend the hill is 4 seconds. Given that the speed of the cyclist at the top is this much, 7.5, find his speed at the bottom. Now, remember this thing. Let me highlight this. When it says that there is a variable thing, has a variable magnitude. The resistive force has a variable magnitude. That means F is equals to MAS, simply not applicable because the acceleration is not constant. So that is why I have to use energy method. What is the formula that I use? The formula that I use is work done by cyclist. That's on the left-hand side of the equation is equals to change in potential plus change in kinetic plus work done against resistance. That is what I use. So now work done against resistance is given. Power is given. Time is given. So power is rate of work done. In other words, this thing over here, power is into time is work. So work done by the cyclist, this one over here, that is 480 joules. That is there. Now it's descending. It's going down. So since it's losing height, therefore, the change in potential energy is negative. And naturally, we know that if the speed over here is 7.5 down the hill, it will be more. So I'm not using that thing at the moment. I'm just letting change in kinetic remain as change in kinetic. So that is change in kinetic, that is change in kinetic. I'll make that the subject. Now look over here. What is the change in potential? That is mg sine theta into distance along the plane. Let me also write it over here. So therefore, change in potential energy is m, which is 80 into g into sine theta into distance along the plane. That is 32.2. This thing goes in this place. And yes, it's a negative sign. There is a negative sign over here. Now, when I put everything in its place, I find change in kinetic energy, which is 640. Now, what is change in kinetic energy? That is half m final velocity square minus initial velocity square. Initial velocity is 7.5, that is square. Let me make v squared the subject. So therefore, v comes out to be 8.5 meter per second, and that is an exact value. No need of rounding off. So that is a nice question. Now, this question, the last question, the last part I'll do fresh and almost fresh. And the first part, let's have a look. Now it says the diagram shows a track ABCT which lies in a vertical plane. The section AB is a straight line inclined at 30 degrees and it's smooth. So this part over here, this is smooth. This part over here is rough. This part over here is also rough. Now it says the section BC is a horizontal straight line rough. CD is the straight line that's also rough, but it's inclined at 30 degrees. Every single length is of 2 meters. A particle is released from rest at A. The coefficient of friction between BC and CD is mu. So it's released from rest. There is mu, there is mu. There is no change in speed of the particle when it passes through either the point B or C. That means it would come down and slowly move this way and slowly goes up this way. It won't jump or nothing like that. First part, it is given that mu is 0.1. Find the distance when the particle has moved up the section CD when its speed is 1 meter per second. That means if it's moved up over here till 1 meter per second, what are they asking? The distance which the particle has moved up the section. So how much is this distance? First thing first, the smooth portion, u is 0, acceleration is g sine theta. Why is it g sine theta? Let me write over here. This is mg sine theta, and this is acceleration. So therefore, mg sine theta is ma, therefore a is g sine theta, the component of gravity down the plane. And s is 2 meters. So let me just shift this thing a little bit over here, like this. So now, if I apply this equation, v square is u square plus 2as, I get v is equals to root 20. That's the first thing. The second thing, the rough portion, the horizontal portion. Now, there is the forward force is 0. The backward force, the resistive force is F max. This is R, this is mg. So F max is mu R. That is mu mg. So therefore, over here, this thing that is 0 minus F max is mass into acceleration. M and M cancels out. A comes out to be negative 1 meter per second square. Now, the previous final velocity now becomes initial velocity. So now from stage 1, that V from stage 1 now becomes U of stage 2. So therefore, U is root 20 meter per second. That is what we are using over here. So we plug in U, we plug in acceleration, which we found distance is 2 meters. V comes out to be 4 meter per second. Now in the last stage, the V from that part will now become U. So U is 4 meter per second. And it will go up till its velocity drops to 1 meter per second. But before that, I need to find what? I need to find the acceleration. So this is 0. This is mg sine theta. This is F max. This is R over here. This is, let me just move this thing up because it's getting all messy over here. So now like this. And this thing is mg cos theta. So R is equals to mg cos theta, and F max is equals to mu R mu mg cos theta. So now let me write it over here. First of all, I have mg sine theta, and then I have mu mg cos theta, that is equals to mass into acceleration. The m cancels out, and let's look at the working. This is 10, this is minus, this is sine 30, this is mu, this is 10, this is cos 30 is A. This comes out to be negative 5.866. So this is negative this thing. That is for this green thing. We have U, we have V. What are we looking for? We are looking for S. The final answer for S is this thing. So very elaborate working for 5 marks. Not very difficult, but the second part is more difficult. Less marks, but more difficult. Now it says it is given instead that with a different value of mu, the particle travels 1 meter up the track from C before it comes instantaneously to rest. Find the value of mu and the speed of the particle at the instant it passes C for the second time. Now the first stage remains the same. That is unchanged. Why? Because that is a smooth plane. So V is still root 20 meter per second. Now over here for the second stage, what is happening? Again, the forward force is 0. The backward force is F max. And this thing over here, let me just shift this thing down a bit. So now over here, U is the same thing as the previous V, which is root 20 meter per second. Now what is unknown over here? For the second stage, mu is unknown. M and M would cancel out. That's not an issue. So acceleration is coming out to be in terms of mu. That thing is done. Now v square is equals to u square plus 2as. So this a is plugged in over here. This u is plugged in over here. Distance is 2 meters. So now I'm getting v square as this thing. No need to take the square root. Just leave it as it is. Now, what should we do? Let's go to the third stage of the journey. So for the third stage of the journey, let me write it over here. That is like this. Now, let me draw this particle like this. And let me write the necessary detail just like before. 0 minus mg sine theta minus mu mg cos theta is equals to mass into acceleration. It's the same as before, except mu is unknown. So now 0 is 0 minus 10, m cancels out. This is 10, this is sine of 30 minus mu minus 10 is there. This is cos of 30. This is acceleration. So now I can either work in the exact form. I think that would be really good. So therefore, this is minus 5. And this is 2, and this thing cancels out. 5 root 3 mu, that is acceleration. So let me highlight this thing. That is the acceleration that we have. Now it's moving up 1 meter. So u square is 20 minus 40 mu from the previous stage. And distance is 1 meter. And this thing is there, this thing is there. Now we have this, we have this, we have this. What are we looking for? We are looking for what? That is, it comes to rest. So now, yes, one other thing, v is equals to 0 because it comes to rest. So let's equate all of them. V square is equals to, hold for a second, v square is equals to u square plus 2as. That is 0 square is equals to u square, which is 20 minus 40 mu, plus 2 into a is negative 5 root 3 mu into s is 1. Now looks like a weird equation, but that's how it is. 20 minus 40 mu, 2 into negative 5, negative 10, 2 into negative 5, negative 10 root 3 mu. Now let's transfer this to the other side. 40 mu plus 10 root 3 mu. 20 minus 30 is 10. That's good. So now take mu common out. Take 10 common out. Take 4 plus root 3 is equals to 10. Let me double check my working. So this is 40, this is 10. I took 10 common out. From here, 4 is left. Mu is also common out. And from here, root 3 is left. All good. So now let me cancel off this 10 and this 10. And what are we getting mu as? So mu is 1 over 4 plus root 3. That is the exact value. They are not asking for the exact value. So let me convert it into decimals. So therefore, this comes out to be 0.1744, which comes out to be 0.174, correct to 3 significant figures. And last but not the least, that is now on the way down. So now on the way down, what is happening? So that is the inclined plane. This is 30 degrees. This is the particle over here. Initial velocity is 0. Acceleration should be a new one. Now, what is the acceleration? Now, mg sine theta is this one, and F max is over here. So mg sine theta minus mu mg cos theta is equals to mass into acceleration. So this is 10, this is sine of 30 degrees, this is 0.1744, this is 10, this is cos of 30 degrees is equals to acceleration A. So therefore, A comes out to be positive 3.489 meter per second square. Now, it has moved 1 meter up, it will be coming down 1 meter. So now let me mark all these points. We have S, we have A, we have U. This thing is there. this thing is there. So what are we looking for? We are looking for the speed. V square is u square plus 2as. Lot of calculation in the last part. So that is 0 square plus 2 into 1 into 3.489. That is v square. Therefore, take the square root, and that comes out to be 2.64 meter per second. And that is how you get an A star with all this elaborate kind of working. So that's how this paper is done and dusted, May, June 2024, M1. And that was one tough paper. Take care, everyone.